Now I'd like to talk about three of the most important functions defined over lists. And they have a special place because they're not only generic, like the ones we've just seen, but they're also higher order. And I will explain what I mean by that as we introduce them. So the first function is called map. And what map does, it takes a function as an argument and it applies that function to every element of a list. And you can see in the definition here, I've given it a definition using a list comprehension. One of the things you can do in a list comprehension is transform every element. And the name for the function that does that is map. Now, if you look at the type of map, you can see the first argument is a function. It's of type A arrow B. The second argument is a list of A. And so if we apply the function to each of those A's, we'll get a B. So the result is a list of B. And I've just shown an example of taking the absolute value of two numbers. It just removes the minus sign when there is one. So this is generic, but what makes it special is the fact it has that function as an argument, and I'll talk about that shortly. Going hand in hand with map is the function filter, and that takes, again, two arguments. One is a function from A to booleans, and you can think of that as a property. Why is it a property? Well, if I give you an element of type A and you apply that function to it, you'll either get the answer true or the answer false. So it's saying the function encapsulates the idea of doing a test, and you'll either get the results true or you'll get the result false. And so we have a property of objects of type, values of type A. We have a list of A, and it returns a list of A, and what it does is return those X in the original list for which Px is true, those which have the property. So map transforms everything, and it's a transformation part of a list comprehension. Filter chooses some elements, and that's the filtering part of a list comprehension. But as I said, these are special for this reason. If you look at the type of map, it makes the function general purpose in two ways. It's first of all applicable to any type of list. So it's generic in that sense, but it's also general in the sense that the actual conversion, the transformation that it does, is a parameter. That first argument is a parameter which encapsulates the particular transformation that is to be done. So this one definition puts together working over lists of any type and working with every transformation over that type. So it's as general as it possibly could be. And it's satisfying to see. It's a very simple definition using that list comprehension. In the next block, we'll see it defined using recursion as well. Now, in a similar way, filter is general purpose in these two ways. It's applicable again to any type of lists, selecting element from that list. But it's also general in that the property over A is itself any function that goes from A to bool. And so you can do the filtering at every type, and you can do it with every property. So again, it's this higher order nature that makes it so powerful. What do I mean by higher order here? I mean that you have an argument which is itself a function. And we'll also see that there are very sensible functions that are return functions as results. They're again called higher order. But one particular advantage of these is that you get very nice APIs when you are able to put functions as arguments. The API of map, it applies to any transformation over any kind of list. Filter applies to any property over any kind of list. And being able to write things in such a general way has meant that this idea of writing higher order functions has percolated away from just languages like Haskell, into most other programming languages. So for example, Java has lambdas, and lambdas are precisely the thing you need in order to write functions as arguments. So these ideas have percolated into all sorts of languages a long way from the functional, because it's such a nice, it's a powerful way of building very general functions and then putting those into an API. So we have map and filter, and map and filter conversely are the things that underpin any implementation of list comprehensions, because that really is about transformation, i.e. map, and filtering, i.e. filter. The third function I wanted to talk about is a combination of zip and map. And here we have, look at the type, it takes lists of type A and B and it produces a list C. And how does it do that? It does that by applying the function to elements chosen from A and B. And the way that they're chosen is you zip together corresponding elements of the lists X's and Y's, and then you apply that F to those elements. So for example, if I do zipWith here, the function plus on these two lists, I'll get 23 added to 17, which is 40, and 31 added to 1, which is 32. So again, this is higher order because it takes that function as its first argument. What we'll do next is put some of these functions into practice in a pictures case study.